Let us see this one. This is a very important question. Okay, the question is saying a ray of light is directed horizontally. So you can see this is the incident light and it is coming horizontally. So okay, towards two long plane mirror x and y. So this is the mirror x, this is the mirror y, which are both at 45 degree to the horizontal. So you can see this dotted line is the horizontal line, this is the horizontal line, and they are making 45 degree as shown in the diagram, right? After two reflections, the ray is traveling horizontally again. So you can see ray incident, then reflection, then again reflection, and it passing horizontally once again. Mirror x is now rotated clockwise through less than 45 degree. So now it is rotating clockwise. So it is rotating in this manner, right? In a clockwise manner,
Yeah.
but less than 50. So it means its final position will be in between horizontal and this current position of the mirror. After this rotation, mirror x makes an angle of theta. So see here, we have this angle theta. After the rotation from the horizontal, angle is theta. So can we find how much it has rotated? Can we find how much it has rotated? See, initially total angle was 45. See, like this, it's come here. After rotation, it's come here, and it is saying that this angle is now theta. So can you tell me how much angle it has rotated? So it means it is rotated by 45 minus theta. It has
Yeah.
rotated by 45 minus theta, correct? Okay. After this rotation, mirror x makes an angle of theta with the horizontal when theta, where theta less than 45. The direction of the incident ray is unchanged. So incident ray is still coming horizontally. In what direction and through what angle should the mirror y be rotated? So we have to find in the direction, in what direction and through what angle should the mirror y be rotated in order for the ray to be still horizontal and traveling to the right after reflection from the mirror. So first let me know, have you understood the statement of the question, the purpose of the question, what
Yeah.
he wants to know? So the overall, if I summarize the question, we have the set of two mirrors. Their arrangements I have already explained. There is one horizontal ray. Initially, after the complete reflection, it is going horizontally once again. Now mirror x gets changed by an angle 45 minus theta. Now I have to find the direction of rotation and the magnitude of rotation of mirror y such that the final reflected ray should be again horizontal. Are you getting the question statement?
Yeah.
Okay. Okay. So have you any idea how we can proceed such type of question? Any idea?
Compare the angles
Okay. No, no. See, that
of
also
incident.
correct. Okay. Okay. That also correct. But we should have some conclusion. We should have some results that will help you in solving this question quickly. So the first result is, suppose I have this plane mirror. This is an incident angle, and this is the normal, and this is the reflected angle, right? So this is the angle I, this is the angle theta, or we
Yeah.
can say the reflected angle. So the first concept you should know that if I rotate my mirror by an angle of theta, suppose now I have rotated my mirror at an angle of theta, and I have rotated in which direction? I have rotated in my anti-clockwise direction, as you can see here, right? I have rotated
Yeah.
my mirror in anti-clockwise sense right now. Anti-clockwise, mirror is rotated by anti-clockwise direction, and magnitude is theta. So you know your reflected angle will be gets rotated by an angle of 2 theta. Your reflected angle will gets rotated by an angle of 2 theta. See, let me verify it. See, my
Yeah.
angle of rotation, see, initially my mirror was this straight one. Now the new mirror gets in this direction, that is the angle theta in anti-clock, right? You can
Yeah.
see this was my initial reflected ray, that's why I was confusing. So your new reflected ray gets changed by 2 theta in anti-clockwise, that's why I was thinking that I'm doing wrong, right? So are you getting this result? So if you rotate your angle, if you rotate your mirror by an angle theta, the reflected ray gets modified by, gets rotated by 2 theta in the same sense of rotation, that is the anti-clockwise.
Okay.
Please see, you want to discuss this one, this theta? See, this is the angle between the normal.
No. No.
Yeah, so whatever the angle
No.
of rotation, that is the same angle between the theta, normal. That will no change in the normal. So is it okay now?
Oh, okay.
Okay. So if we have this concept, and there's one another concept, see, there's one another concept. which we should have. If what will happen if I rotate my incident ray? Please see what will happen if my incident ray gets modified. If incident ray rotated by an angle, my mirror is still same, but my incident ray gets rotated, then what will happen? So please read. If the incident ray is rotated through an angle theta, the reflected ray rotated by the same angle theta, as long as the plane mirror remains
Yeah.
constant. So now we have two conclusions, two important conclusions. The first conclusion is if the plane mirror rotated by an angle theta, so the reflected ray will gets modified by 2 theta in the same sense of direction, right? If
Yeah.
incident ray if incident ray gets rotated by an angle theta, then the reflected angle gets rotated by angle theta, right?
Yeah.
Now see here what happening. Initially, see, if we are discussing this question, so we should have some normal. So its normal should be like this. Its normal should be like this.
Yeah.
So I think it's obvious, and I can prove it also. This should be your 45-degree. This should be your 45-degree. If you want to
Yeah.
see its calculation, I can show you. You want to see this? How this is 45 and 45?
Okay.
See, this is the horizontal, and this is also horizontal. So this angle will be also 45, isn't it?
Yeah.
And if this is the 45, this one will be 45. Alternate interior angle. Please see. Is it okay? If this is the 45, this one is the 45. Alternate interior angles.
Yeah. Okay.
And now we have the perpendicular here.
Yeah. Okay. Then 45.
And it is the perpendicular. It means, this complete angle is 90-degree. You are perpendicular on the mirror. So this is the complete 90-degree.
Yeah.
So
Yeah.
this is the 45-degree. And this is the 45-degree. And like this. Similarly, here you have this
Yeah.
normal. And see, now please see. This normal and this normal are parallel lines, isn't it?
Yeah.
And this is a
Yeah.
transverse line. So if this is the 45, so by the alternate interior angle, this will be 45, right? And if this is the 45,
Yeah.
so this one will be 45. I have done this in my office only,
Yeah.
right? I have done this in my office. I was thinking what was going on. So sometimes it happened that questions click, and sometimes the same question cannot
Hello.
click. Yeah, are you getting my voice?
Hello.
Hello, hello. Are you getting my voice?
Yeah. Yeah. Hello.
Yeah, yeah.
Yeah.
I was saying that the same question I have think in my office, and that in that time
Mm.
I have made this little diagram and everything gets clear. But right now I am not able to do this. Sometimes it happened that questions not clicked on the mind. Okay, no problem. So now you have all this. Everything should be clear, right? This is happening initially,
Yeah.
but now what's happening? You have rotated this mirror by angle theta. No, it's not angle of rotation theta. It's the final angle with the horizontal, right? So this angle will be how much? This angle will be 45 minus theta, isn't it?
Yeah.
Just a
Yeah.
minute, actually tomorrow's class. Okay, so this is the 40. So according to our first theorem, we just get that if the mirror is reflected by an angle of theta, we get that if the
Yeah.
mirror gets reflected by theta, so the reflected angle will get rotated by 2 theta, right?
Two. Yeah.
And in the same direction. So see, it is rotated in a clockwise manner. See, our mirror has been rotated in
Yeah.
clockwise manner. So my reflected ray will get rotated in clockwise manner. So clockwise manner, it means in this direction. This is the clockwise manner. It means your this ray should rotate it. It should pass through in this sense, and this angle of rotation should be twice of 45 minus theta. Are you getting my point? See, your mirror has
Yeah.
rotated
Yeah.
in x direction like this, so it is rotated also by an angle of twice of this, right? Okay, now you want that
Yeah.
your angle must be in this direction. So for that we see for the plane, for the mirror y, you can see for the mirror y, for the mirror y, my incident angle is rotated by this much angle. We have the second result that if
Yeah.
the incident ray rotated by theta, if the incident ray rotated by angle theta, then the reflected ray will also get reflected by rotated by theta, right? If the mirror is fixed.
Yeah.
So for the mirror y, this red line, this red ray was incident ray, and it's get rotated by twice of 45 minus theta. It means if the mirror is constant, if the mirror is kept rest, no rotation, so the reflected angle will also gets rotated by twice of 45 minus theta, right? Is it okay now?
Yeah. Yep.
But so
Yep.
if mirror y do not get rotated, so your final ray will gets rotated by angle twice of 45 minus theta. But I want to keep it change. I want to keep it unchanged. I want that it should be at the horizontally. So it means you have to compensate this much of rotation. That is the twice of 45 minus theta, right? We have to compensate this rotation, and this rotation has to be compensated by rotating of mirror y. And we have the relation that if I rotate my mirror by an angle theta, its reflected angle gets rotated by twice of theta, right? Suppose now you
Yeah.
think in reverse manner. Suppose you have to compensate the 2 theta, so your mirror needs to rotate it by theta only. Just reverse it, just think in reverse manner now. Think in reverse manner. If you
Yeah.
want to change, if you want to adjust your reflected ray by 2 theta, so you need to rotate your mirror by an angle theta only, isn't it?
Yeah.
And
Yeah.
now see, my rays goes in which direction? It's an anti-clockwise. See, it's anti-clockwise. So I have to rotate my mirror half of this, that is twice of 45 minus theta. So I have to rotate only half of this, that's the 45 minus theta. So first check the option. See, this is not correct, this is not correct, not correct, not correct. Only these two options should be correct. Now clockwise or anti-clockwise. So we can see that this is in, see, this gets rotated in anti-clockwise, right? It's an anti-clockwise. So to compensate
Yeah.
this, I have to rotate my mirror in clockwise sense. So I think its answer should be clockwise 45 minus theta. Please see the answer and tell me, is it correct or not? Either E or F, both are probable. It should be E. Please check it.
Which number
This question
question?
is 29.
Okay.
These are the very conceptual questions. Everything needs to be crystal clear.
Answers E.
Yeah, that's correct. We are getting the same.
Yep.
So have you understood
Yep.
how we have done this? So two results which we have discussed in the beginning of this question, that is very necessary. Otherwise, you have to do a lot of calculations and overall you will get confusion. Are you getting my point? So these
Yeah.
two
Yeah.
results are very
Yeah.
necessary. So can we move?
Yeah.